For 4 seconds, the most powerful camera ever pointed at the night sky saw something, and then its own software erased it. This isn't a glitch. It isn't a cover-up. It's by design. The Vera C. Rubin Observatory, high in the mountains of Chile, was built to do something no telescope has ever attempted.
The presumption was stars near the center of a galaxy would be orbiting very rapidly, and stars at the outside would be going very slow.
Stars would not be bound in this orbit. They would fly out.
The regions of Andromeda that were quite far out were still rotating quite fast.
And the first thing it does with almost everything it captures is delete it, subtract it, wipe it out of existence before a single human ever looks. But every so often, in that flood of discarded light, something slips through that should not be there. 10 days before the world knew it existed, this telescope had already seen it, and nobody noticed. Tonight, what the machine throws away and the one thing it almost lost forever. To understand what got deleted, you first have to understand what this machine actually is. On a ridge called Cerro Pachón, nearly 9,000 feet up in the Chilean Andes, sits an 8.4-meter telescope feeding the largest digital camera ever built, 3,200 megapixels, roughly the size of a small car. On June 23, 2025, the team behind it released its first images to the world, and they were unlike anything astronomy had produced before. Here's the part that matters. Each single frame covers a slice of sky as wide as 45 full moons. The telescope doesn't stare, it sweeps, snapping around 1,000 images every night, scanning the entire southern sky every 3 to 4 nights, then starting all over again, and again, for 10 years. Think about what that really means. Most telescopes take a portrait. This one is shooting a movie of the universe, frame by frame, night after night, hunting for the one thing other telescopes miss: change, a star that suddenly flares, an asteroid drifting where nothing was before, something that's there one night and simply gone the next. And in its very first real test, just over 10 hours of observations, it found 2,104 asteroids no one had ever seen, 7 of them near-Earth objects. For scale, every other observatory on the planet combined discovers around 20,000 in an entire year. This thing did 1/10 of that before breakfast. But to find the things that move, the telescope first has to erase everything that doesn't. And that's where the deleting begins. Because the universe, it turns out, is mostly made of stuff this machine is built to throw away. Here's how it works, and it's stranger than it sounds. Every time the camera takes a new image, software instantly compares it against a template, a master picture of that exact patch of sky, stitched together from all the previous shots of the same spot. Then it does something almost violent. It subtracts the old from the new. Every star that was already there, gone. Every galaxy sitting quietly in the background, erased. The entire static universe, the part that never changes, is mathematically deleted. What's left on the screen is almost nothing, a near black frame, and floating in that darkness, only the things that are new, the things that moved, the things that flared or shifted, or vanished. That tiny residue of change is what triggers an alert, and the system fires one within about 2 minutes of the photo being taken. Now hold that number in your head, 2 minutes, because the scale here is about to get genuinely disorienting. On a single night in February 2026, the observatory pushed out around 800,000 alerts, 800,000 separate "something changed here" flags in one night. And that's the system barely warming up. At full speed, scientists expect it to generate up to 10 million alerts every single night. No human can review 10 million of anything, so nearly all of it is handled by software that decides in a fraction of a second what each blip probably is. A supernova, a pulsating star, a feeding black hole, a passing asteroid, and what's just noise to be ignored. The program lead himself described it plainly. Because they image the sky so fast and so often, they'll catch millions of changing objects every night. Most of what this telescope sees, it sorts and moves past faster than you can blink. It has to. The alternative is drowning. And here is the first thing that should make you uneasy, and we'll come back to this. The same system that's clever enough to flag a distant exploding star is also making split-second judgments about what counts as real and what gets dumped as garbage. Most of the time it gets it right, but most of the time is doing an enormous amount of work in that sentence, because there's something crossing these images that was never supposed to be there at all. When astronomers first dreamed up this telescope back in the 1990s, the sky above Chile was nearly empty. A lone satellite drifting past now and then, nothing more. Then came the mega constellations, Starlink, thousands upon thousands of bright satellites now streaking across the sky, especially at twilight. And simulations suggest that as many as 30% of this telescope's images could end up with at least one satellite trail slashing straight through them. A bright line, there and gone in seconds, photobombing the most sensitive camera on Earth. And here's the genuinely dangerous part. According to the observatory's own scientists, these streaks can obscure, or even masquerade as, real astronomical phenomena. A fast glint of reflected sunlight can look, for an instant, almost exactly like something profound. The observatory's chief scientist called it a collision between two beautiful technologies. So the team fought back. The software now hunts down these trails and masks them out, paints over them, flags those pixels as contaminated, deletes them from the science data entirely. A satellite appears for a heartbeat, and the system surgically erases it before it can poison the results. Which brings us to the uncomfortable question this whole story is built around. If the telescope is forever deleting the static universe, and forever erasing the streaks that don't belong, then what happens when something genuinely strange flies through, something that looks to a piece of software exactly like junk to be thrown away? What if the single most important thing this telescope ever caught was something it was built to ignore? Because that very nearly happened. Keep this in mind, the telescope's whole genius is rejection. It is, at its core, a machine for forgetting, built to delete the 99.99% of the sky that stays the same, so the rare, the new, the impossible can finally stand out. Its discoveries don't come from what it keeps. They come from what it's willing to throw away. And in those very first months, before the official 10-year survey had even begun, the telescope was still in what's called commissioning, basically a rehearsal. Engineers testing systems, sweeping patches of sky almost at random just to confirm everything worked. Nobody was hunting for anything in particular. These were practice runs, throwaway data. Buried inside one of those practice runs was an object that had traveled here from another star. On July 1st, 2025, a completely different telescope, a survey called Atlas, spotted a faint smudge moving through the solar system. Within days, astronomers confirmed something almost unbelievable. It was an interstellar object, only the third ever discovered, a wanderer born around another sun that had drifted into our neighborhood. They named it 3I/Atlas. And here's where everything snaps back together. Once scientists knew exactly where to look, they went digging back through Rubin's discarded commissioning images, the practice frames nobody had been combing for discoveries. And there it was. The telescope had photographed 3I/Atlas on June 21st, 10 full days before the world even knew it existed. It had been sitting in the data the entire time, captured, recorded, and functionally invisible, because no one, and no alert, had flagged it as anything worth a second glance. In total, Rubin had quietly caught the interstellar visitor across dozens of images, in detail sharp enough to become the earliest high-resolution record of an object from beyond our solar system that we possess. Let that settle for a second. The third interstellar object ever detected by our species passed through our sky, and the most powerful survey telescope on Earth photographed it before anyone was looking, then very nearly let it slip past unremarked. Just another blip in a torrent of millions. Exactly the kind of thing the machine is built to delete. That's the truth behind the 4 seconds. It isn't a secret. It isn't a conspiracy. It's something far more humbling. This telescope sees so much, so fast, that the act of deciding what to erase has quietly become one of the most important and most fragile decisions in modern science. The discoveries are real, but so is everything we throw away to find them. and the survey hasn't even properly started yet. Within its first 2 years, this machine is expected to uncover millions of new asteroids, and in early data alone, it's already blown past 11,000. So the next time you see a flawless, silent image of the cosmos, remember what it took to make it. Remember that behind every clean picture is a torrent of light being sorted, judged, and deleted at a scale no human mind could ever hold. Millions of decisions a night about what's worth keeping and what disappears forever. We built a machine to watch the entire sky change, and in doing so, we built a machine that has to forget almost everything it sees. The wonder isn't only in what it finds, it's in the quiet, unsettling thought of what might be slipping through the cracks right now, tonight, in 4-second flashes that no one will ever go back to review. An interstellar visitor already hid in plain sight once. It almost certainly won't be the last thing that does. If this rewired the way you look at the sky above you, stay with the channel, because we're going deeper into what Rubin finds next, and some of it is going to be even harder to explain.